Something is happening beneath Mars that should not be happening. NASA instruments are picking up signals that do not match a cold, dead planet. Layers beneath the surface are reflecting radar in ways that are difficult to explain. Strange bursts of methane appear in the thin atmosphere and then vanish without warning. Nothing about this pattern is stable. Nothing about it is simple. For a planet that looks like a frozen desert of red dust and broken rock, Mars is starting to look far more complex beneath the surface. And the deeper scientists look, the more unusual the data becomes. Mars is often described as a dead world, a place where nothing moves, a place where nothing survives. But that idea is based only on what we see. You make America, the surface of Mars is harsh. It is dry. It is exposed to constant radiation. It is shaped by dust storms that can cover the entire planet. At first glance, it looks like a world that lost its life long ago. But orbiters circling Mars tell a different story. Landers sitting on its surface tell another. And rovers moving across its terrain add even more mystery. These machines are not just taking pictures. They are scanning beneath the ground. They are analyzing gases in the air. They are collecting signals that human eyes could never detect alone. NASA missions like Mars Reconnaissance Orbiter and other radar-based instruments have been sending waves into the ground. These waves bounce back with patterns that reveal hidden layers. Some of these layers look like ice. Some reflect in ways that suggest materials mixed with water. Some signals do not match any known simple structure. In some regions, radar readings show thick deposits beneath the surface. These deposits are not random. They appear organized in layers, as if something has built up over long periods of time. Scientists believe much of this is ice mixed with dust, but not every signal fits neatly into that explanation. Then there is methane. Methane is one of the most puzzling discoveries on Mars. On Earth, methane is often produced by living organisms or by geological processes deep underground. On Mars, methane appears in small bursts. It rises in concentration. Then it disappears. Then it returns again. This cycle has been detected multiple times over the years by orbiters and ground-based instruments. The strange part is stability, or rather, the lack of methane in the Martian atmosphere should break down quickly under sunlight. That means something must be producing it now. Not in the distant past, not billions of years ago, but at present. No single explanation fully matches all observations. Some scientists suggest underground chemical reactions between water and rock. Others suggest trapped gas released through seasonal changes. A small number of hypotheses even consider the possibility of microbial activity beneath the surface. None of these ideas has been confirmed. The mystery remains open. As data continues to build, another question begins to form. What lies below all of this? Mars has a surface that tells one story, but beneath that surface, there may be an entirely different world. Radar scans suggest buried ice sheets stretching across vast regions. Some of these ice deposits are so large that they could fill entire oceans if melted. In certain areas, signals suggest something even more unusual. Layers that behave like liquid or semi-liquid material trapped beneath frozen ground. This raises a critical possibility. If liquid water exists beneath the surface of Mars today, even in small pockets, then Mars is not fully inactive. It would mean energy, chemistry, and movement still exist deep below the frozen exterior. The surface of Mars is exposed and vulnerable. Solar radiation constantly strikes it because Mars lost most of its protective magnetic field long ago. This radiation destroys organic molecules and makes survival on the surface extremely difficult. Temperatures drop far below freezing. The atmosphere is thin and cannot hold heat. Yet below the surface, conditions could be very different. Rock and ice can act like insulation. Radiation decreases with depth. Pressure increases. Temperatures stabilize. In these hidden layers, environments may exist that are far more stable than anything on the surface. This is why scientists are now focusing not only on where water once flowed, but where it might still exist today. The search has moved underground. Each new mission adds another layer of complexity. Each new reading challenges older assumptions. Mars is no longer being studied as a simple dead planet. It is being studied as a layered system with a visible surface and a hidden interior. The question is no longer only about what Mars was. The question is about what Mars still is. And as these signals continue to emerge from beneath the red dust, one idea becomes impossible to ignore. Mars may not be as silent as it appears. Welcome to the channel. If you are fascinated by space, hidden worlds, and the deepest mysteries of the universe, subscribe now. Because what comes next may completely change the way you see not only Mars, but every planet that looks lifeless at first glance. Mars today looks dry, cold, and lifeless. But the surface tells a very different story when you read it closely. Hidden across its valleys and plains are signs that this planet was once completely transformed by water. Long ago, Mars may not have been red and dusty. It may have been blue and flowing with liquid water. Evidence from orbiters shows deep channels carved into the ground. These are not small marks. They stretch for hundreds of kilometers. Some of them are wide enough to suggest massive rivers that once moved with force and volume. These river-like structures are not random. They split into networks. They branch and reconnect. This pattern is very similar to river systems on Earth. On Earth, such patterns form only when water flows over long periods of time, not days, not months, but possibly millions of years. Then there are ancient lake beds, flat regions surrounded by raised edges. These look like dried basins where water once collected and slowly disappeared. In some places, sediment layers are stacked in ways that suggest still water standing for long periods. Calm water, not rushing rivers. Quiet lakes that may have lasted for thousands or even millions of years. One of the most striking discoveries comes from mineral analysis. Certain minerals found on Mars can only form in the presence of liquid water, not ice, not vapor. Liquid water that interacts with rock over time. These minerals are scattered across different regions of the planet. That means water was not limited to one area. It was widespread. Some geological formations even resemble ancient coastlines, long curved boundaries between high and low terrain. These shapes look similar to shorelines on Earth, where oceans meet land. Scientists have mapped these features in multiple regions, and the patterns are difficult to ignore. There is also the mystery of timing. Some evidence suggests Mars had water for a very long time, possibly long enough for environments to stabilize. Long N, AWI, for chemistry to become complex. Long enough for conditions that could support life, at least in simple forms. But something changed. Mars did not slowly dry in a simple way. It seems to have lost its water in stages. Some water may have evaporated into space after the planet lost its magnetic field. Some may have frozen underground. Some may still be trapped beneath the surface even today. This leads to one of the biggest questions in planetary science. If Mars once had oceans, rivers, and lakes that lasted for such a long time, then where did all of it go? And more importantly, how much of it is still hidden beneath the surface, waiting to be discovered? Deep beneath the frozen surface of Mars, something unusual begins to appear when scientists look with the right instruments. NASA orbiters do not just take images, they send radar waves into the ground. These waves travel through layers of dust, rock, and ice, then they bounce back. The way they return tells scientists what is hidden below. Two of the most important tools for this are shared These radar systems can see far beneath the Martian surface, much deeper than any camera or lander could ever reach. And what they reveal is unexpected. Across the polar regions, thick layers of water ice stretch far below the ground. These are not thin frost layers. These are massive deposits stacked like frozen archives of time. Some are kilometers deep. They hold a large portion of all the water that Mars still has today. But the story does not end at the poles. Radar signals show that ice is not limited to the coldest regions. In mid-latitudes, far away from the poles, there are also signs of buried ice, sometimes covered by only a thin layer of dust and rock. This means water is not just a relic locked at the ends of the planet. It is spread in hidden pockets across Mars. In some regions, the radar reflections behave strangely. Instead of clean, simple layers, scientists see bright, strong echoes that suggest something more complex beneath the surface. These unusual signals have led to a controversial idea. Some researchers believe that in certain places, the ice may not be completely frozen. Instead, it could be mixed with salts, known as perchlorates. These salts are important because they can lower the freezing point of water. On Earth, salty water can remain liquid at much colder temperatures than pure water. This opens a difficult possibility. Deep underground, where pressure is higher and temperatures are more stable, There may be briny liquid water trapped in pockets or thin layers, not flowing rivers, not open lakes, but hidden salty reservoirs that do not behave like normal water on Earth. Some radar readings even show reflections that are harder to explain with pure ice alone. These layers appear smooth and dense in ways that raise questions. Scientists are careful with these interpretations because radar data can be misleading, but the patterns keep appearing in different regions from different instruments. Another detail makes this even more intriguing. In certain slopes on Mars, seasonal dark streaks appear and fade over time. These features, sometimes called recurring slope lineae, have been linked by some scientists to the movement of very small amounts of salty liquid water. Others argue they are caused by dry dust flows. The debate is still open, but the timing and behavior of these streaks continue to attract attention. If even small amounts of liquid water exist today beneath the surface, it changes how Mars is understood. Water is not just a memory locked in ancient rock. It becomes something active, something still present in hidden environments. Below the frozen crust, Mars may not be completely dry. It may still be holding on to reservoirs that have survived for millions of years, sealed away from the harsh surface conditions. And the deeper the data goes, the more the planet begins to show signs of hidden complexity that was never visible from above. Something in the thin air of Mars should not be there at all. Methane has been detected again and again by NASA instruments on the surface and in orbit. The Curiosity rover has measured it directly in the Gale crater. At times, the readings are almost nothing. Then suddenly, the levels rise. Then they fall again. This pattern repeats without a stable explanation. Methane is a simple gas, but on Mars it becomes a deep mystery. Under sunlight, methane should not last long. The thin Martian atmosphere is harsh. Solar radiation breaks chemical bonds quickly. That means any methane found today must be recent. It must be produced right now or very recently. Otherwise, it should already be gone. This is where the problem begins. No single source has been confirmed. On Earth, methane often comes from living organisms. It is released by microbes, wetlands, and biological decay. That is why methane on Mars immediately raises difficult questions. But biology is not the only option. There are also geological processes that can produce methane without life. One possibility comes from reactions deep underground. When certain types of rock, like olivine, interact with water, they can produce hydrogen. That hydrogen can then combine with carbon compounds to form methane. These reactions can happen far below the surface, hidden from direct observation. Another idea involves ancient trapped gases. Methane could be stored underground in ice-like structures and released when conditions shift. Temperature changes, pressure changes, or seasonal cycles could trigger small leaks to the surface. But none of these explanations fully match what is observed. The most puzzling detail is the pattern itself. Methane levels do not stay constant. They rise in certain seasons. They fall in others. This seasonal behavior suggests a system that is active and changing, something that responds to time, temperature, or environmental cycles. Even more strange, different instruments have sometimes reported different methane levels at the same location. Orbiters detect one pattern, rovers detect another. This inconsistency has made the data even harder to interpret. Some readings show sudden spikes, small bursts of methane that appear and disappear quickly. These spikes are difficult to explain with slow geological processes alone. They suggest something localized and active. Because of this, two main ideas continue to compete. One idea is purely geological. Deep rock reactions, hidden reservoirs, and slow underground chemistry producing gas over time. The other idea is more controversial. It suggests the possibility of microbial life existing beneath the surface, shielded from radiation and extreme temperatures. No evidence has confirmed either explanation. What is clear is that methane is not evenly distributed. It is not constant. It behaves like something that is being produced, released, and then hidden again. Each new measurement adds another layer to the puzzle. Each spike raises more questions than answers. And as scientists continue to track these fluctuations across seasons and years, the source of this gas remains one of the most persistent. IS on Mars. Deep beneath the frozen crust of Mars, radar signals begin to behave in ways that do not fully match solid ice. Instead of clean, simple reflections, some regions show distortions, layers that seem uneven, areas that respond like something softer or partially unstable is hidden below. These are not direct images. They are echoes. But even echoes can carry clues. Scientists studying data from instruments like CHARAD and MARSIS have noticed that certain subsurface regions do not behave like pure rock or pure ice. The signals bend and brighten in ways that suggest unusual materials are present under the surface. This is where one of the most surprising ideas enters the picture. On Earth, water freezes at 0 degrees Celsius. But Mars is not Earth. It is colder, drier, and filled with salts that change everything about how water behaves. One group of salts found across Mars is called perchlorates. These are highly reactive chemicals. On their own, they are harsh and unstable. But in water, they create something unusual. They can lower the freezing point of water dramatically. This means that under the right conditions, water on Mars does not have to be fully frozen. It can stay liquid even in temperatures far below what is normally possible. This opens a new possibility. Instead of large oceans or flowing rivers, Mars could contain hidden pockets of briny liquid water, thick salty mixtures trapped beneath layers of ice and rock. These pockets would not behave like lakes on Earth. They would be dark, cold, and isolated, but still liquid. Some radar readings from the South Polar region have drawn special attention. Beneath kilometers of ice, scientists have detected a bright reflective zone. This zone is flat and consistent, unlike the surrounding frozen layers. Some researchers suggest it could be a buried saltwater lake. The idea is controversial. Radar signals can be misleading. Dust layers, volcanic deposits, and ice structures can sometimes produce similar reflections. But the pattern beneath the South Pole has remained one of the strongest candidates for a hidden liquid region. If such a reservoir exists, it would be protected from the harshest conditions on the surface. Mars has no strong global magnetic field. This means radiation constantly hits the ground, breaking down organic molecules. The surface is exposed and extreme, but below T, Hick ice, conditions change. Ice and rock can act as shields. They block radiation. They stabilize temperature. They create pressure that can keep water from freezing, especially if salts are present. In these protected zones, chemistry can continue in ways that are impossible on the surface. This is why scientists take these radar anomalies seriously. They are not just looking for water in the past. They are searching for environments that could still exist today. There are also smaller hints scattered across other regions of Mars. Certain slope features change seasonally. Dark streaks appear and fade. Some scientists believe these could be linked to tiny flows of briny liquid water moving just beneath the surface. Others argue they are dry processes involving dust and sand. The debate continues without a final answer. But the idea of subsurface liquid is no longer limited to theory alone. It is becoming a working hypothesis tested against every new data set. If even small reservoirs of liquid water exist beneath Mars today, they would represent environments completely separated from the surface. Environments hidden, stable, and potentially active in ways that remain unknown. And D, this leads deeper into one of the most important questions in planetary science. The surface of Mars gives a powerful first impression. It looks quiet. It looks empty. It looks frozen in time. But that impression hides a far more complex reality. One of the most important facts about Mars is that it no longer has a strong global magnetic field. On Earth, the magnetic field acts like a shield. It deflects charged particles coming from the sun. It protects the surface from constant radiation. Mars lost this protection long ago. Without that shield, the surface of Mars is exposed directly to space radiation. High energy particles from the sun and deep space constantly hit the ground. Over time, this radiation breaks apart chemical bonds. It destroys complex molecules. Even organic compounds cannot survive for long on the surface under these conditions. This creates a harsh environment where stability is almost impossible. Then there is ultraviolet light. Mars has a thin atmosphere, much thinner than Earth. This means there is very little protection from UV radiation. On the surface, sunlight is not just light, it is a chemical force. It can damage molecules in minutes. Any potent organic material exposed at the surface would degrade quickly, but radiation is not the only problem. The planet itself is unstable in terms of environment. Dust storms can grow massive, sometimes covering the entire planet. These storms can last for weeks or even months. They fill the atmosphere with fine particles that block sunlight and change surface conditions. Temperatures also swing to extremes. Near the equator, daytime can feel relatively mild in sunlight. But at night, temperatures drop rapidly to levels that can freeze most known forms of life. Near the poles, conditions are even more severe, with long periods of deep cold. From the surface alone, Mars looks completely hostile. But this is where the story becomes more complicated. Beneath the surface, everything changes. Rock and soil begin to act like insulation. They reduce radiation exposure dramatically. Even a few meters of material can block most harmful particles from reaching deeper layers. This creates a protective environment that does not exist above ground. Temperature also becomes more stable underground. Instead of sharp day and night changes, conditions become steady. Heat from the planet's interior slowly moves outward, creating a more balanced environment. This means that while the surface of Mars is extreme, the subsurface may be far more stable than expected. Some scientists describe this as a hidden zone where basic chemistry could continue without interruption. Water, if present, would be protected from evaporation. Organic molecules, if they exist, would be shielded from radiation damage. Energy sources from underground reactions could still operate slowly over long periods. This is where the idea of a hidden biosphere begins to take shape. A biosphere does not have to exist on the surface. It only needs the right conditions. Liquid water, chemical energy, stability over time. On Mars, those conditions may not exist above ground, but below the surface, they may be present in isolated pockets, tiny regions protected from radiation, enclosed environments sealed beneath layers of ice and rock, places where chemical processes could continue without being destroyed by the harsh surface. Nothing has been confirmed. No direct evidence of life has been found. But the structure of the planet now suggests something important. Mars may not be a single environment. It may be laid red, a hostile exterior hiding a very different interior. Mars no longer fits the simple idea of a dead planet. The surface still looks cold, dry, and empty. But every layer beneath it tells a different story. Ice hidden under dust. Radar signals that do not fully match solid rock. Gas that appears and disappears without a clear source. None of it fits the old picture of a quiet, inactive world. Instead, Mars now looks like a layered system. A surface that hides everything below it. And beneath that surface, there may be water that never fully disappeared. There may be chemical reactions still happening deep underground. There may even be environments that remain stable enough to support processes we do not yet fully understand. Each mission that studies Mars adds more detail, but also more questions. The more we learn, the less simple the planet becomes. It is no longer just a frozen desert in space. It is a world with a past that was active, and possibly a present that is still active in ways that cannot be seen from above. The most important shift is not just about water or methane or radar signals. It is about how we define a lifeless planet. Mars keeps pushing that definitively. On further away, what once looked like a dead world may actually be a world that moved its activity underground. Future missions will go deeper than ever before, not just orbiting above or driving across the surface, but drilling into the layers beneath. They will search for chemical signatures, They will analyze hidden ice. They will look for any trace of environments that are still active today. That is where the real answers may be found. Because if even a small form of life exists below the surface of Mars, it would change everything known about life in the universe. It would mean life is not rare. It would mean life can survive in places once thought impossible. It would change how humanity sees its place in space forever. Mars is still speaking through its hidden layers. The question is how deep those layers go and what is still waiting beneath them. If you enjoyed this journey into the hidden side of Mars, make sure to like the video and subscribe for more deep space discoveries.